All right, so now we're moving on to the next chapter, which in your chapter, this is going to be, or in your book, this is going to be chapter 17. And that is going to be quadratic functions. All right, so this is chapter 17. And before we get started, I'm just going to go through a few things with the function because our book just kind of jumps straight into it. And in case you guys don't remember or whatever, just going to go through a few things. So a quadratic function is a relationship between two variables which can be written in the form y is equal to ax squared plus bx plus c. However, when we are saying or denoting that something is a function, I want you to use this form. So when we say something is a function, we would represent it by this f of x. That's how we read it. But it also lets us know it's a function. Or you can use any letter out front, g of x, h of x, t of x. There's other letters you can use up front. It doesn't have to be f of x. But the ones that we typically see most will be this F, G, and H. That's typically how they get denoted. But this, where we write F and then a parentheses X, it's read F of X. And that lets the reader know that this is a function. And when we know something is a function, there's a few characteristics that we know right off the bat. One is that for every X value, there is exactly one Y. All right, meaning if we try to substitute, so if I said find the value of y when x is 3, it can only generate one value back for us. It can't say, well, when x is 3, y can either be 2 or y can be 1. That will not be a function. For every x value that we substitute in, there is only one y value that we can get back. All right, so you could be given a set of ordered pairs. 1, 2, 2, 3, and 3, 4. And I can ask you, is this a function based on these ordered pairs right here? And you would say yes, because no x value repeats and gives us a separate y value. If I give you this and I add 0, 2, and I ask you, is this a function? You might be inclined to say, well, no, it's not because there is a repeating y, but that is okay. You can have different x values give you the same y value in return, but you cannot have one x value give you two different y's. So this is still a function. And if I add this one, 0, -3, then this is where it does not become a function because the zeros repeat and they give us different values. So for every x value, there is only one y. But you can have multiple, you can have different y values have different x, but you can only have one x value, or for every x, there is only one y. All right, and one of the other ways that you can think about this is there's another test that gets done. If you've ever seen this, it's called a vertical line test. So if I draw some graphs, so if I draw this graph here, to say this is what our graph looks like, this blue line, and I ask you, is this a function? You can draw these vertical lines throughout your graph. And if it ever intersects your graph at more than one point, then it is not a function. But since all of these vertical lines intersect our graph at one point, then this tells us it is a function. All right, so that blue graph is a function. However, if I were to draw this red graph, and we go to do the vertical line test on this, here it intersects at two different points. So that tells me that one x value generates two y's. So this one is not a function. All right, so for every one x value, there is exactly one y. All right, so just make sure you think about that. There's one x. For every x value you have, it's going to generate one y value. Right, but it doesn't necessarily mean it has to be vice versa. We can have a y value give us two different x values like I showed you here. All right, so now we're just going to go through and solve a few different questions with this equation, with quadratic functions. All right, the first type that we're going to do is where you're going to be given x, you're now going to find y. And that's easy. When you're given x, you're trying to find y, all you need to do is just substitute it in. So x is equal to 0, so we're just going to quickly substitute it in. Y is equal to 2 times 0 squared plus 4 times 0 minus 5. So y is then equal to -5. So when x is equal to 0, y is equal to -5. That would be our ordered pair. All right, so we just plug it in, and then we just solve. The next one, when x is equal to 3. So for b, x is equal to 3. So that means y is equal to 2 times 3 squared plus 4 times 3. Minus 5. So 3 squared is 9. 9 times 2 is 18. 4 times 3 is 12. Minus 5. So this will then give me 30 minus 5, which is 25. So when x is equal to 3, y is equal to 25. So when you're given x and you're asked to solve for y, it's really easy. You just plug it in, you raise it to the power if there is power, which there would be in this chapter because we're only dealing with quadratic functions. And then you multiply, add, and subtract. All right, the next type of problem is going to be finding x when you're given y. So as we've learned before, when we are solving for x, we can get multiple answers. We can get where there is going to be one solution, which we've talked about in class. That means that our graph lies exactly on our x-axis. We can get where there's two solutions, so that tells us our graph is crossing our axis twice. Or we can get no real solution, which means our graph is never crossing our x-axis. So the same holds true when we're solving quadratic functions. When we're given y and we're trying to solve for x, we can get 0, 1, or 2 possible real solutions. All right, so let's go ahead and do this. So when we're solving for x, we just substitute in for y. So the first one tells us y is equal to 15. So we get 15 is equal to x squared minus 6x plus 8. So in order to solve for this, we need to set it equal to 0. So we'll subtract 15 from both sides. So x squared minus 6x minus 7 is equal to 0. All right. You can use any of the methods from this point forward to solve. I'm going to use quadratic formula for this one, and then I'm going to factor the next one. So our a is equal to 1, our b is equal to -6, and our c is equal to -7. So our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over top of 2a. So then that tells me it's negative of a -6 plus or minus the square root of -6 squared minus 4 times 1 times -7 all over top of 2 times 1. So then this will give me positive 6 plus or minus the square root of 36, because -6 squared is positive 36, plus 28 all over top of 2. So 6 plus or minus the square root, well, 36 plus 28 is going to give me 64 over top of 2. And the square root of 64 is 8, so it's 6 plus or minus 8 over top of 2. So now this gives us two different possibilities. So we can do 6 plus 8 over 2 or 6 minus 8 over 2. So that means it's 14 divided by 2, which is 7, or 6 minus -8 is -2 divided by 2 is -1. So that means when y is equal to 15, x can be equal to 7, or x can be equal to -1. So it will generate these two ordered pairs. All right, the next one for b, I'm going to do in green, and y is equal to -1. So then it's -1 is equal to x squared minus 6x plus 8. So we need to set it equal to 0 first. So we get x squared minus 6x plus 9 is equal to 0. All right, now you could use a quadratic form if you'd like to, because not every problem that you get will be able to be factored. So trying to do factoring first sometimes can maybe waste some time. So a lot of students I had in the past, they'll just jump straight to quadratic formula because they know it works every time and all the time. Factoring, not everything can be factored. However, you can look at these and say, well, can these be factored? And if you can quickly see it can, then go ahead and factor. And I know that something we learned before, a perfect trinomial square, where if I take the square root of x squared and 9, I get x and 3. If I multiply them together and double it, I get 6x, which matches my middle term. So I know this is a perfect trinomial square, so I can rewrite this as a binomial squared. And if the two square roots get written in, so it's x and 3, and then our sign here, the minus sign, gets written. So I know that this factors out to x minus 3 squared. I can then take the square root of each side. X minus 3 is equal to 0. Add over 3, add over 3. So that means x is equal to 3. So when x is equal to 3, y was equal to -1. And that is our answer for that one. All right, now the last type of problem that we will have is this word problem here. So it says a stone is thrown into the air at a height above the ground, a stone is thrown into the air. Its height above the ground is given by the function h of t is equal to -5t squared plus 30t plus 2 meters, where t is the time in seconds from when the stone is thrown. How high is a stone above the ground at t is equal to 3 seconds? So for that one, we just need to go ahead and substitute in for t. So t is equal to 3. So that means h of 3 is equal to -5 times 3 squared plus 30 times 3 plus 2. So then here we would get 3 squared is 9. 9 times negative 5 is negative 45. 30 times 3 is plus 90 plus 2. So then our h of 3 is equal to negative 45 plus 90 is 45 plus 2 is 47. So when t is equal to 3, we are 47 meters above the ground. All right, so whenever you're given it seconds and you just plug it in, it tells us how high we are. Now the next one says, from what height above the ground was a stone released? So now when we are given that question, well, if the stone is just being released, what is our seconds at? How many seconds have passed since we've thrown it? None, because it hasn't left our hands yet. So when it's being released, our t is at 0. So we would then go ahead and solve for how high we are when t is equal to 0. And in the future, you will actually learn, if you ever take calculus or physics, you'll learn right off the bat which number is going to represent our initial height. So that would be plus 30 times 0 plus 2. So then this will give me 0, this will give me 0. So then our h of 0 is equal to 2. So that means when our t is equal to 0, our height was 2. So our initial height, how high we are above the ground when we're throwing the stone, or how high the stone is above the ground, from when it's being released, it's 2 meters above the ground, right? 2 meters. So we can be standing on a low hill, or maybe just where your trajectory is of your arm, it's being released 2 meters above the ground. And then the last part is, at what time is the stone's height above the ground 27 meters? All right, so let's go ahead and think about this for a second. We know an x squared or a t squared is going to give us a parabola. If it's being released 2 meters above the ground, and we know it at least releases 47, that means twice this answer is going to go and reach 27 meters where it wants, because here we know this will at least be at 2. We know that this one's going to be at 47. Since it's a negative, it's facing upside down. And we know our parabola or a quadratic gives us a U shape. So this tells me I'm going to have 2 different answers for this one, because I know it's got to reach 27 as it's getting up to the 47, and then it's going to stop and turn around, and it's got to reach back down to the ground, so it's going to pass that 27 again. Not that you need to draw this, not that you really need to know it. I'm just kind of helping you think a little bit of how these graphs can relate to us with solving the questions. And sometimes if you think about it in terms of your graph before you go to answer, then you should know that you will have 2 answers for this one. Right? So when we're doing this, we need to say that we need to set our y equal to 27. So our last part, it will be 27 is equal to negative 5t squared plus 30t plus 2. So now we need to set it equal to 0. So I will subtract over the 27. So negative 5t squared plus 30t minus 25 is equal to 0. I want this t to be positive, and I see that they're all factors of 5. So that means I'm going to factor out this negative 5. So now I'm left with t squared minus 6t plus 5 is equal to 0. Now I'm going to get rid of this GCF. Since it's an equation, I can divide it on both sides. So then I get t squared minus 6t plus 5 is equal to 0. If I look at this, I can go ahead and jump straight to the quadratic formula, but I know that there are multiples of 5 that add up to 6. It's 5 and 1. So that means that this is going to factor out to t minus 5 times t minus 1 is equal to 0. If you're unsure about how I did that so quickly, just use any of the methods that you do, whether if it's the x method or anything else to factor that. Then if 2 numbers or 2 factors multiply and equal to 0, that means one of them has to be 0, so we set them equal to 0. We add over our 5, we add over our 5, we add over our 1, we add over our 1. So that means t is equal to 5 or t is equal to 1. So that means at 5 seconds or at 1 second, our height is 27 meters. So we can write this as an ordered pair, or you can just leave it as t is equal to 5 and t is equal to 1. But what this is telling us is that at 1 second and at 5 seconds, our height is at 27. Right? That is it for this video.